Today we are finishing activity 16 by combining lessons 16.3 and 16.4. So in today's video, we're proving that a quadrilateral is a rhombus, and then we're also going to prove how a quadrilateral can be a square. So we're starting on page 230 in your Springboard book. Okay, so in order to prove something is a rhombus, let's remind ourselves what characteristic makes something a rhombus. So remember, a rhombus is a parallelogram with four congruent sides. Four congruent sides. So our most basic kind of definition of a rhombus, if I drew a picture here, would be a parallelogram with four congruent sides. So all sides we know are congruent. Okay. So this brings us to our first theorem. If a parallelogram has two consecutive congruent sides, then it has four congruent sides and is a rhombus. Okay, so how do we know if it has two congruent sides, it automatically has four? Well, here's why your book kind of explains it. If it is a parallelogram, okay, we know that the opposite sides are going to be congruent. We'll know the opposite sides are going to be congruent. So if they're consecutive, if this one is congruent to this one, consecutive angles are congruent. Okay, by transitive property, we can kind of also replace it and say that the other two are going to be congruent as well. Okay, and if it has four congruent sides, that parallelogram by definition would be a rhombus. Okay, that brings us to another theorem. If a quadrilateral is equilateral, meaning all sides are the same, then again, it is a rhombus. Okay. So we're not going to really write a proof, but to explain why number 3, that theorem is true, this is what your book kind of said. If all sides of a quadrilateral are congruent, then both pairs of opposite sides are congruent. Hence, the quadrilateral is a parallelogram by definition, then making it a rhombus. Okay. Let's look at number 5. We're going to use some theorems here to prove the last theorem there on that page. But it says, given that the parallelogram kind has perpendicular KN perpendicular to ID. So let's kind of mark that. KN is perpendicular to ID. Okay. List the 3 triangles that are congruent to triangle KXD. So let's list. So we have 3. They're saying congruent triangles. 1, 2, 3. Okay, so let's look at KXD is one triangle. So we have to say what other ones are congruent. Now, because they told us this was a parallelogram, we can make some assumptions here by their diagonals have to bisect each other in a parallelogram. So I'm just going to mark those here. So if I'm looking at this picture then, we have some reflexive property. So KXD would have to be congruent to triangle KXI. Okay, which is also going to be congruent then to NXI. Okay, this triangle here. And then we also have a congruent to, let's say, NXD. And the reason we can say that is because we have side angle sides. Using the fact that those parallelograms have a bisected diagonals, reflexive property gives us our third side. And if they're perpendicular, all those angles are 90 degrees. So we know those are also congruent. Okay, so then by our good friend CPCTC, we can list some segments that we know are congruent. So we could say like KD, for example, is then congruent to KI, which is also congruent to NI, which is also congruent to ND. Okay. So if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. Because we just proved if they are perpendicular, we can get corresponding parts, making all of our side lengths congruent, which if a parallelogram has 4 congruent sides, it's a rhombus. Okay. Let's go on to the next page here. Let's talk about how we can prove that something is a parallelogram. Now, there's 4 methods here that your book kind of talks through, so that's what I'm going to do. So given we have a quadrilateral bird with coordinates for B, I, R, and D, the way that we can prove something is a parallelogram is by, one way is to prove that their opposite sides are parallel. So you could find the slopes of the opposite sides, okay? And see, do those slopes, are they the same slope? Because then they're parallel lines. Method 2 would to see if both of your pairs of opposite sides are congruent. So if you found the length of each of those sides using distance formula, so that would be probably a hard one to do. You'd have a little bit more work, but you can use that to find the distance, or if you graphed it out, if it's a straight line, you could count it. Okay, but if you saw the opposite sides were congruent, that's one way to prove a parallelogram. Method 3, to show that the opposite sides are congruent and parallel. Okay, if you just prove one pair of those sides fit that criteria, then you can prove that something is a parallelogram. And lastly, if you can prove the diagonals bisect each other, and we did this kind of in 16-1's video, or if you find the midpoint of each diagonal, if the midpoint is the same point, then you can prove that they bisect each other and sense is a parallelogram. So that's 4 methods you can do to prove that something is a parallelogram. You just have to do one, but you kind of have 4 different ways to do it. So if I kind of piggyback off that idea, to prove that something then is also a rhombus, the easiest way to probably do that is to use method 4 here. Prove that those diagonals bisect each other, but you also have to show that the diagonals are perpendicular, because that was a specific property in our family tree that was true for a rhombus. So if you showed method 4, they showed that diagonals bisect each other, and you also show that they're perpendicular, then you can prove a rhombus. Okay. All right, our last theorem for rhombus here is if we have this picture here, parallelogram west with TE that bisects angles WES and WTS. So let's mark that. If it bisects it, we know it cuts it in half. So we know angle 1 and angle 2 are congruent. Same thing with angle 3 and angle 4. Okay. Now again, if we know this is a parallelogram, we know some things about their sides. Their opposite sides are parallel. So let's think about that. List all angles that are congruent to angle 1 and explain why. Well, from our picture from the bisector, we know angle 1 is also congruent to angle 2. But because we have parallel lines, what else can I say is congruent to angle 1? Well, hopefully you said you know that angle 1 is congruent to angle 4, because those are alternate interior angles. And then by transitive property, then we can say that angle 1 is also congruent to angle 3, because that's congruent to angle 4. So here's kind of all of our things. So angle 1 and angle 2, angle 3 and angle 4 are all congruent to each other. Angle 1 and angle 2, angle 3 and angle 4 are congruent by the bisector, angle bisector. And then the alternate interior angles are angles 1 and 4, 2 and 3. So again, kind of by some transitive property there, we can kind of say that those are also congruent. So all 1, 2, 3, 4, those are all congruent angles. Okay. So now in triangle WET, WT has to be, so let me kind of remark our picture here because this is going to help us. So we just showed that all of these angles are congruent to each other. Okay, so in our picture, WT then would have to be congruent to WE. Same thing with ST, have to be congruent to SE. Okay, because if your base angles are congruent, the base angles of a triangle are congruent, that implies, okay, your opposite sides are also congruent. Okay, so if the diagonals bisect a pair of opposite sides, didn't really give us enough space to write this in here, but that's okay. Okay, Okay, so our last theorem here, if a diagonal bisects a pair of opposite sides in a parallelogram, then that parallelogram is a rhombus. Okay. So let's just go on the last page here and we're going to summarize this. So to summarize, to prove something is a rhombus, you can show that that quadrilateral has 4 congruent sides. That's one way. You can also show that the consecutive sides are congruent, so next two sides. Or you can show that the diagonals of a parallelogram are perpendicular, or show that a diagonal of a parallelogram bisects a pair of opposite angles. Okay. Those are the kind of the 4 ways to prove something is a rhombus. All right, so let's just do a couple practice problems down below here, and then we'll move on to the squares. So let's just look at problem 14. So find the value of x that makes a parallelogram a rhombus. So let's start with 14. How can you set up that equation? Look at what it gave you. It looks like it gave you some alternate interior angles. So how can you set up your equation and solve for x? Okay, this one ended up actually being a little tougher than it looks because we can set those up by knowing that they are congruent. We just showed that the opposite angles in a parallelogram are congruent. So your book is only using 5/2 as a reasonable solution. So this problem ended up being a quadratic equation that I factored. And if I factor this, I can solve each of these for x. So we get 5/2 and -1. But if I plug in -1, it still would give me a positive angle, because that would be 2 times -1 squared, which is still 2. 3 times -1, that's -3 plus 5, so that's also 2. So I think both answers personally work. Your book is only using the positive one. Okay, why don't you guys try B now? Now B is probably going to be a little easier to solve, but set up a way that you can solve for x for B. Okay, here's what I did. I got x was 1. So if that is a rhombus, that means that all 4 sides are congruent. So I just set 3x plus 1 equal to 10x minus 6. And we get that x is 1. Okay. All right, let's finish this now with talking about how to prove that something is a square. Okay. So what information is needed to prove that a parallelogram, JKLM, is a square? So there's 2 ways we can prove this. One of the ways is to say that all sides are congruent. So we have 4 congruent sides. And we need to have 4 right angles. Okay, because if it just has 4 congruent sides, that could be a rhombus. But if it has 4 congruent sides and 4 right angles, then we could say it's a square. The other way we can prove something is a square is by using its diagonals. So we could say that the diagonals bisect each other. Bisect each other. Okay. The diagonals also have to be perpendicular. And the last thing we have to say is the diagonals are congruent. Again, if the diagonals are just perpendicular, we could technically call that a rhombus. But if they are congruent and perpendicular, that is unique for a square. Okay, so that's the information we would need for B here. That's how you can prove that something is a square. Now, the next couple questions are just asking what additional information you would need to prove. So if they said this is a rectangle, JKLM, what would you need to know to say that it is a square? Well, the 2 things you could say is if it's a rectangle, you already know that all the angles are 90 degrees. So the additional information you would need to know is that all the sides are congruent. Okay. Or you'd have to know that the diagonals are perpendicular. Remember, in a rectangle, the diagonals are also congruent. So that part is already unique for a rectangle, but to prove that something's a square, they'd have to be congruent, but also perpendicular. Okay? Now, what if they told you that JKLM is a rhombus? If you wanted to prove that that was a square, it has all the properties of a rhombus, but what's unique for a square is that all the angles are 90 degrees. Okay. Or again, the diagonals are perpendicular. And congruent. Okay. All right. So the difference between a rhombus and a square is basically in the angles. Okay. If you can prove that all the angles are 90 degrees and all the sides are congruent, then you have a square. If you can only say that all four sides are congruent, then you have a rhombus. So that's kind of the difference. So remember, the square has the most properties. Okay, so that's the most restrictive shape that we have in this parallelogram family. But if you can prove all those things about a square, then you have that. But remember, rectangles, rhombuses, squares, okay, they all fall under that parallelogram umbrella. Just a matter of looking at those unique properties for each shape to be able to prove which one is which.